Hola amigos, yo soy Andreas, soy de Austria, but I think I switched to English because my Spanish is simply not good enough. Well, I'm very honored to speak at this conference. The topic is a guide to event-driven SRE-inspired DevOps. I know this is a lot of words, but believe me, what I'm really going to show you is a new approach on how we can do continuous delivery better, a modern approach to delivering operations actually. My name is Andreas Grabner. I'm a DevOps activist at a company called Dynatrace, but what I'm also doing, I'm a DevRel for an open source project called Captain. You'll find more information about that open source project on the bottom here, how you can follow us, how you can star us, how you can Slack us. Captain is a CNCF, a Cloud Native Computing Foundation sandbox project. And my talk will focus very much on this open source project today. So in case you are interested in learning more, this is all the information you need. Now let me get started. For those of you that are doing DevOps or whatever your organization calls it, I assume that if you are responsible for a delivery pipeline and building a modern delivery pipeline, that you're asked to build something that resembles what you see on the screen here. Multi-stage delivery, like in my screenshots here, I have version 3 of my simple node service deployed in dev, staging, and prod. And I think what we need to do as an industry, or what our organizations want from us, is that we make it as easy so that the developer can simply make a pull request that triggers the build of a new container, let's say version number 4 of that image. It gets automatically deployed and tested. It then gets evaluated against quality criteria or SLOs, service level objectives. And if all of this is good in dev, it can be automatically promoted into the next stage where, again, we expect the pipeline to deploy automatically, to even run more tests in staging, again, evaluate if this version in staging under more load and more tests is still good enough, meets all of our objectives. And if so, then we want pipeline maybe to not automatically promote into production, but have the capability to say, I have a new artifact that was tested and now do you want to promote it, yes or no? If you are a release manager or whoever is responsible for production, you can say, I want to pull this into production. Now, if you do this, you probably also want to leverage progressive delivery models like blue-green or canaries. So the pipeline should support it. Let's say doing a blue-green deployment, but then very importantly, evaluate again if the new version is actually good enough in production as well with real traffic. So it's important to evaluate your SLOs again. And if they fail, then the pipeline should automatically toggle back to the previous state. However, also making sure if you toggle back, that you're actually back in a healthy state. So it's very important that the pipelines always reevaluate. So I think this is one thing we're asked for in modern delivery, to automate as many steps as possible and to include new concepts of SLO-based validation and also progressive delivery models like blue, green, and canary. But this is not all, because once things are in production and there is a problem coming in, let's say you have a monitoring system that alerts, then you want that monitoring system to raise a flag, and then you want your software to automatically say, what is wrong? What can I execute as an action? Let's say scaling up could be one action that should be automated and not manually being clicked. Very important is that your system should then also again evaluate, did the action actually bring the system back to a healthy state? If not, maybe execute another action and then roll back to its healthy state. And this is what we call about when we talk about automated operations. So this is what we're all asked to deliver. And there's many talks out there, maybe just as mine, where I start now, would say this is all possible. However, in reality, we know that a lot of organizations, and I'm sure you're working for some of those, they are not there. We've only seen 5% of people we surveyed and we've worked with in the last couple of months with Captain that they're truly not there. And Captain really tries to address a couple of problems we have seen when working with these organizations that we think prevents them from actually getting to that stage. On the one side, it's wasting time with maintaining traditional pipelines. It is a lot of time wasted in manual tasks along delivery, and in operations, it's a lot of time wasted in manual remediation. So these are the 3 sections of my presentation. First one, I make the claim that 95% of delivery engineering time is wasted in maintaining monolithic pipelines. What do I mean with this? This is a screenshot of a pipeline that we have internally. It's Jenkins-based, only 350 lines of code. It's already a big problem because it's a monolith. So it's not the size necessarily, but the problem with these traditional pipelines is that you have mixed information about process, target, platform, and environment. So in that file, somebody specified what's the process, Where do we deploy to? Which tools do we use? Everything is hard-coded in that pipeline, which means you have no clear separation of concerns on who is defining the process, who is defining the tooling, and how do I really interact as a developer with it. And I think this is a problem. As also another problem is that, I'm not sure if you have ever built pipelines, but if you start with a pipeline that works well, then maybe you end up copying, pasting it over for other projects or services. You make slight, small modifications so it fits your needs. And if this actually works, then over the next months or years, you may end up having a lot of people in your organization using a slightly modified version of your original pipeline. And now if something breaks, it's very hard to figure out why does it break, who actually built in this little piece of code, who brought in that plugin, which is now outdated. So this is where a lot of people, I think, and what we've seen, are spending a lot of time in maintaining and fixing these classical monolithic pipelines. Now, what we want to bring up is a new way of doing this, and it's an event-driven way of delivery. So what do I mean with this? The solution is to remove hard dependencies. So on the left side, you have a classical, let's say, workflow in continuous delivery. And on the right side, you have typically the hard-coded integrations with your different set of tools. So what we want to do is we want to rip these two things actually apart. We want to define the process on one side and have the individual actions on the other side. And just as in modern software architecture, where we also have seen monoliths being broken apart into smaller pieces and entities, we're using eventing to connect the two pieces again, to connect the process with the tooling, which means if we have a tool that can orchestrate the execution of a process by sending events, one of those events could be, I need to deploy container number 1 as blue-green in dev. And then a tool that registers for these events that can say, I can actually do this type of delivery, can then act upon it and say, I do the delivery, and is then reporting back through an event whether this delivery succeeded or failed. And based on that, the process goes on. So in the end, really what we need to do is we need to rip these two things apart, clear separation of concerns between process definition and tool definition, and we have eventing to make all of this work together. Now, Keptn actually solves this exactly with this approach. So when you install Keptn on Kubernetes, you get a control plane that is responsible for the application logic. So all the workflows, it uses eventing to then trigger events as it executes workflows. Now the first piece is defining that process. So here we call it a shipyard file, where if you are, let's say, a site reliability engineer in your organization and you're responsible for the delivery and operations workflows, you can say, I have a dev, a stage, and a prod environment. You specify what type of deployment strategy you want, direct, blue-green, canaries, and what type of test strategy you want. This defines the process. Then, completely separated, you specify the tooling. Tooling could be the DevOps team, or maybe the platform team, or the tooling team in the organization can say, here are the tools that we want to use for configuration management, for deployment, for testing, for validation, for monitoring and remediation. In Keptn, this is called the so-called uniform. So which tools are listening to which type of events? The beneficiary of this is the developer. Because once this is set up, the developer can simply say, I have a new artifact, and then please, Keptn, bring this artifact safely into the harbor, which is production. And Keptn is really executing the workflow by sending an event, in the beginning a configuration change, then a deployment event, then a test event, and with this, moves the artifact forward. The great thing is, at any time, the process can be changed by one team, the tooling can be changed by other team, the developer is still interacting with it in the same way. So that first demo that I want to do is actually the stuff that I've shown earlier. So I have a 3-stage pipeline. I have a very simple sample app, and I have deployed it in version 3 in dev, staging, and prod. And in order to kick version 4 up, I simply do Keptn send event new artifact through the Keptn CLI. And what it does then, Keptn, for me, it uses Git to store my configuration change. It updates my Helm chart. I'm using Helm for deployment. It then does a direct deployment. It then executes some tests, then enforces a quality gate by looking at test results and additional monitoring data if you want to. Then I've turned on automated approval, which means if this is good, it gets automatically deployed into staging, where the same thing happens at the end as a quality gate. And then in my demo, I specified I don't want automated approval in prod, but I want manual approval, which means I get asked, do you want to promote this into production? And if so, the same process goes on, git change, Then I do a blue-green deployment, then tests are run to make sure that everything is also still good in production. And then the quality gate is again analyzed and say, this is a good build, yes or no. And if so, we keep it or we roll it back. So let's have a quick look at my demo. So I have Keptn installed on an EKS cluster. I have a project that is specified like this. Remember, this is the dev stage, this is staging, and this is prod. This is my whole process definition, my whole pipeline file, basically. And then the only thing I need to do is once this is up and I've onboarded my individual Helm charts and I've given Keptn my test files and my quality gate files, then I can simply say Keptn send event new artifact. Oops, here we go. And I basically said Keptn is organized in projects, in services, and then I just give it a new image and a version. So let me quickly jump over to the Keptn's bridge. This is now the UI where I can actually see I have build number 4 deployed in dev. So let's quickly open this. This is my sample app. Build number 4 runs in dev. I also have build number 4 running hopefully in staging. So let's open this one. It's in staging. Again, it's a simple Node.js based microservice. And in prod, I have build number 3 still running. Right, this is build number 3, different background color, different build number. But what you can see here, Keptn tells me that there is actually a new version available. Build number 4 would be available because it made it all the way through staging with 100% of the points. And now I can click the button here. And now the process continues, which means Keptn is now continuing the full workflow into prod. Now let me switch over to the process view of this. So this now, if I click on services, I can actually see the build number 4 is the one I kicked off just before we started recording this session. Now, if we go all the way up, I can see here the changes that happen in dev, deployment, test, finish, quality gate. Oops, it's automatically scrolling down every time something happens. So then it went into staging. You can see a configuration change, deployment finished, test finished, and so on. It's always scrolling down whenever there's an update. And it went through the quality gates, fully automated. And that's great. And now, as I'm in production, I triggered the approval. Now Keptn is doing the configuration changes, it's doing the deployments, it's doing some validation, and then keeps my version in production, yes or no, depending on how well version 4 is then also doing in production. So that means, hopefully soon, once this is deployed, this should then automatically go to version 4, fully automated, deployment, test, validation. All right, let's see. Come back in a second after my next demo, then we'll see that this actually did deploy. So fully automated, I have separation of concerns between tooling and between the process definition. Now, one example of one of our users is Patrick from Amazon. They're using GitLab for CI, for building, and then so for testing, unit testing, and compiling, and then building in container images. And once that is done, they're using Keptn with JMeter for multi-stage continuous delivery. Also integrating it with the monitoring tool with all the quality gates. So just that you see, you can very easily tie this in with your existing tools because Keptn can be automated through an API or a CLI. Now, second use case, 80% of lead time is spent in manual deployment validation. What do I mean with this? If you have invested in an existing delivery pipeline, whatever tools you have, I assume you do some building, some deploying, hopefully running some tests. But then what we see with most organizations, you have this phase where somebody has to manually look at test results, whether it's your code coverage, it's your test coverage, or it's things like functional test results. Oh, this functional test failed. Is this critical, yes or no? Well, we don't really know because we haven't really thought about how important that particular thing is. Or if you include a performance testing, which is great, and more people are doing, it's very hard to compare one test with another. Is the increase in CPU, for instance, really bad or not if response time is still good? More and more people are also now including monitoring, whether this is your Prometheus or your APM vendors. So the question, it's great that you have more data, but if this is still not thought through on what is actually important, how does this translate to a test that I ran, then it's just more data and it's very hard to manually analyze. And this is why it takes so long. So our approach now to speed this up is through an SLI and SLO based quality gate approach. Now, in case it's the first time you hear about SLIs and SLOs, I didn't come up with. Google promoted it, even though it's not, they didn't reinvent the wheel, but basically what they said as part of their site reliability engineering practices, we define SLIs as something that is measurable, like the error rate of login requests, some metric that you can get. Then you have an objective, a service level objective, something like login error rate has to be less than 2% over a 30 period of day. This is an objective. And then SLA then is basically the legal agreement, or what happens if we don't meet the SLO, right? So this would be then you are violating some contracts, or you're obviously not making your end users happy. So there's a lot of great information out there from Google and others. I can really encourage you to do this. Now, why am I telling you this? Because I think SLIs and SLOs are great because we can use this in production. Most monitoring tools have native support for it, where you can say, here is my service, here is my app, here are my SLIs, and here are my SLOs for it. And then please report to me every month, how am I doing? Or alert me in case I'm running low on my error budget. But what we thought, this is a great concept and very simple, a metric in a time frame, over a time frame against a threshold. We can also shift this left, which means through what we call Kapton Quality Gates, we can fully automatically analyze key metrics, SLIs and SLOs, but not only in production, but with every commit, right? Every time we push a new build through and run some tests, we can also look at these metrics fully automatically and then get early feedback so we can immediately react on potential problems. Which now brings me to the next demo. So I want to show you how Kapton can be configured with these SLIs and SLOs. I'm using, in my case, Dynatrace as a monitoring solution. There's an integration with Kapton. You can do the same thing with Prometheus or other monitoring data sources. In my case, the only thing I have to do is specify a dashboard with metrics, and then Kapton is pulling these metrics fully automatically every time after deployment or a test is run, and then calculates a score that sits between 0 and 100, and based on that makes an automated decision. So let me go back. First of all, let's refresh. Let's see, here we go. Oh, build number 3 was already rejected again from earlier. So let's actually have a look at this, because the quality gates is actually an essential part of that delivery process. So what you see here is my build number 4 from earlier that was deployed. Kapton automatically analyzed these SLIs, and then it found out that it only achieved 86 out of 100%, but I specified that I need 90% of good quality in order for it to keep it in production. In this case, it triggered a rollback because it was bad. Now, in this particular piece, the quality gate component, which was here used for evaluating if a production deployment was fine, can also be used in any type of stage. And also standalone, which you'll see in a second. But the point here is the way this works, I created a dashboard. In this case, I'm using Dynatrace. I put all the metrics on the dashboard, and instead of manually having to sit there and say, good, bad, I don't know, and then comparing it with the previous time frame, Kapton is fully automatically doing this for me. It's looking at response time P95, P90, P50, my different business transactions, process metrics, memory, event loop, tick count. This is something from my Node.js-based app that I just added here. And I said, please, Kapton, you look at this data for me, and then you can compare it either against the static threshold, if you have one, or against previous builds. Both things are possible. You can see here through the terminal, through the nomenclature on top of here, where you can do pass and warning criteria. So this is how Kapton quality gates work. And this is also why build number 3 is still in production, because it was kicked back for me. So that means no harm to end users, which is also great. Build 4 is simply not good. To give another example, Kapton Quality Gate, a core capability, can be used standalone, and this is very important. So if you have an existing delivery pipeline like Christian from ERT, where they're using GitLab for deploy and for testing, in the verify stage, they simply trigger Kapton, where Kapton is then pulling the metrics from the monitoring tools, from the testing tools, is calculating a score, and based on that says good or no good. That saves a lot of time. Now, last piece is production. Once things are in production, things fail, we're spending too much time in manual troubleshooting. So we want to change this by also including this SRE-driven, SLI, SLO-based approach for remediation. So what that means is Kapton, since its version 0.7, has a closed-loop remediation engine built in. Basically, I showed you earlier how you can define a delivery process in Kapton, and Kapton is using events for delivery. The same now is for production issues. So in case you have a monitoring tool that alerts you on a problem like conversion rate dropped, CPU pressure, then you specify a so-called remediation workflow, where this YAML file on the left, similar but yet different to what you showed you earlier for delivery, allows me to say which actions should be executed in case of a certain problem. Now, the interesting thing is Keptn doesn't just execute an action, fire and forget, and that's it. It executes an action. It is then evaluating your SLIs and SLOs, so making sure that everything is good. If it's good, great. If not, executes the next action, just as a human being would do, and always then evaluating if everything was fine. If everything was fine, good. If not, it would still escalate. Now, while this is great, it's also scary if you try this out the first time in production. This is why what we see is people say this is too risky. Then I say, I understand. So let's integrate this in your testing environments or in your chaos experiments. So if you're using chaos engineering tools, whether it's Litmus, Chaos Monkey, or Gremlin, or any other, you can simulate problems. And then, first of all, you validate that your monitoring works and your alerting works, but you can then use Keptn to actually make sure that your remediation workflows are correctly working. You can then use this to really hardening it, to define and test it out, so that in case this really happens in production, you know you have already tested it, because nothing should end up in production that has not been tested. And that also includes your auto remediation. All right, let's wrap it up. What is Keptn? Keptn is an event-based control plane for continuous delivery and automated operations. We have a clear separation of concerns between the process definition and the tooling. We're using cloud events as a standard protocol to let these tools communicate, and it's very easy to build your own tool integration, so to replace things. We set out to solve these three problems. Actually, we solved more than that, but these are the three problems I focused on today, because we want to make sure that more organizations can deliver fast and operate better without having to do too much manual work. Now, if you want to get started, tutorials.keptn.sh is a great starting point, or just go to our website or GitHub. And I really now hope that you enjoyed the talk, and hopefully there's also questions that are coming in. Here's a lot of more information in case you want to get a hold of me later on. But thanks for having me. Muchas gracias. And thank you so much. Bye-bye.
Hello, can you hear me? How are you?
I can hear you, yeah. Thanks for switching to English, because my Spanish is simply not good enough.
That's okay, that's okay. Say hi to the audience. They're here on the Q&A to just asking some questions. So I'm just going to start because time is very, very tight today. So Edward, I have the first question. What's the real difference between SRE and DevOps? Most voted question.
I know it's a loaded question. I think I tried to answer it on the chat earlier. I think it's really hard to differentiate the two, because I think in the end, both are following the same goal of allowing our organizations, the companies we work for, to deliver better value faster to our end users, where I think DevOps is a big movement of transforming your organization to use more automation, to focus on automated everything, automate infrastructure, automate deployment, automated testing, automate monitoring. SRE, site reliability engineering, I think is really one of the practices around helping your organization to build, architect, and deploy resilient systems. So I think overall, it's under the same umbrella, but site reliability engineers focus more on the reliability and the resilience of your systems, and DevOps is really a big movement. There's a lot of cultural change that also has to go into this, which means trust. Trusting in the people, trusting in the systems that you can automate. It's a loaded question. It's hard to answer.
Yeah.
And if I give an answer, I'm sure I find many people that say this is not the right answer, because there's no right answer.
Exactly. So, all right. Next question is, what are the first steps to start with DevOps?
Again, I think the best way to start from a technical perspective, and I'm an engineer, is automation.
Okay.
I think automation is key, because everything you can automate means it saves you time. It's also more fault tolerant. It produces better results. I think the first way towards DevOps is automation. Now, I think the best way of doing it is doing a value stream analysis, which means look at your organization. What I typically do when I go to a company, I say, show me a single code change and what is involved of getting this code change into production. This is a value stream analysis from a delivery pipeline. And basically there you typically see a lot of manual tasks, handovers, people manually have to look at things. So I think it's a great way to start in automating tasks that are repeated by somebody, and then also rethinking things. How can we do things differently in the future? And a last big thing that is very important is, in the end, I think we're all humans and we want to feel proud of what we do, because if we feel proud of what we do things with more enthusiasm. And therefore, I think it's also a great thing from DevOps to say, let's make people more responsible for what they do. But responsibility is not only we are smashing you in case you did something wrong, but we also award and reward you in case you did something great. So I think it's the whole, what Jeff, what from what Emerson said, you build it, you run it. I think that's a great cultural change that says, I'm an engineer, I come up with the idea, we build it together as a team, and then we're also responsible for out there in production. So we make sure we automate as much as possible. We build safety nets in there. We build monitoring in there, so we know how it's running out there, and so we can also then be happy if it works well.
Awesome. So automate, that's the thing. So next question, most voted question. Do you have an example of some company using this in production right now?
Yeah, and I think Leandro is the guy who asked. I answered some of the names. I think he was referring to Keptn. So we have Amasol, Avodac, ERT. These are three of the examples. We have a couple of customers in Belgium. We have customers users in the US. It is an open source project. You can go to the Keptn GitHub page. You'll find an adopters file. This is where the people that officially also are allowed to say that they're using it and they want to get the name out there, they have entered their names. And if you are just Googling for Keptn adopters, you'll find a couple of webinars we did with some of the adopters. So there are adopters out there.
Awesome. Okay, next question. How does Keptn manage debugging issues in an event-driven architecture?
Yeah, so Keptn, I know it's a hard name to pronounce because
yes.
Keptn, it's the German phonetic for a captain. I'm from Austria, so the whole idea came out of Austria. That's why that's the way it's pronounced. But debugging issues in an event-driven market. So Keptn itself is an event-driven architecture. So we heavily, obviously, rely on logging for this, but also distributed tracing. Now, we at Keptn, we are fortunate enough because we are also our let's say main company that we all work for is Dynatrace, and Dynatrace is a software intelligence platform which automatically does distributed tracing in event-driven architecture. So we internally actually use Dynatrace for our debugging, for our development. There's also some blog posts that we have already posted on how we actually use Dynatrace in our day-to-day development work to find problems in our architecture. Now, I think the question also goes towards how does Keptn manage debugging in event-driven architectures where Keptn deploys event-driven architectures. This then I think depends on your implementation, your monitoring, your tracing tools that you're using, and I'm sure it will be some combination of metrics, traces, and logs.
Awesome. Okay, next couple of questions. Is Keptn open source? You already answered that. It is open source. Yeah. So the next one is, can Keptn replace Jenkins? Wow.
Yeah, I know. So I think we don't want to necessarily replace Jenkins. We think Jenkins is a great tool for continuous integration. This is also why Keptn, we don't do continuous integration. We start with continuous delivery. So we see a lot of integrations where Jenkins actually calls Keptn to either do the quality gate that I've shown in my presentation or to do the delivery into a certain environment. We also have the other option where Keptn can own and orchestrate the whole end-to-end delivery workflow, but can then call Jenkins for individual tasks. So I think, yes, we can replace Jenkins in certain aspects where I think Jenkins doesn't make sense, but on the other side, we don't want to replace something where it's not necessary. This is why we built this event-driven system where other tools like Jenkins can call Keptn to do a certain thing, or Keptn can call Jenkins to also do a certain thing along the delivery process.
Cool. Next one. So I guess you kind of answered this one. So it's from Ezekiel. How does Keptn integrate with other tools or custom tools for stuff? I guess you just answered.
Yeah. So we have a in my presentation I talked about the event-driven architecture, and we have so-called Keptn services. So that means Keptn sends events, and these events are picked up by so-called Keptn services. So if you want to integrate a new tool, you can write a Keptn service, which basically just has to listen on a port, and then you register or you subscribe to a Keptn event, like a deployment event, a test event. And with this, you can really integrate any type of tool. Now, if you want to know which tools have already been integrated, which Keptn services have already written, you can go to the Keptn Git project, but we also have a Keptn Sandbox and a Keptn Contrib Git organization. So we follow the CNCF, the Cloud Native Computing Foundation best practice of having a core project, that's Keptn. Then we have a Keptn Sandbox. This is where new projects start. And then once they are mature enough and we have enough adoption, we move them to Keptn Contrib contributions. So you will find already integrations with testing tools, with deployment tools, with tools like Argo. We have Litmus Chaos Engineering. We have Neotis testing. We have integrations with GitLab. We have integrations with Slack. These are already out there, but everybody is free to build their own integrations.
Good. So we have about 2 minutes left. So next question is, Leonel asks, what is the difference between the containers? Does that make sense?
I think Leonel has asked this question also, I saw earlier in other chats. I'm not sure if it really makes sense from me, but the difference between,
that's fine. So we'll move to the next one. So let's make this will be the last question. So is it possible to use Keptn only to analyze data from Prometheus to validate SLI/SLO?
The answer is no. I mean, Prometheus is one of the data sources. In my demo, I've shown the integration with Dynatrace. Now, as with any other integration, Keptn uses the event-driven architecture. That means whether you have Prometheus, or in my case, Dynatrace, or any other monitoring tool or any other data source, I think Splunk was mentioned in the chat earlier, you can create a so-called Keptn SLI service for a particular data source, and then Keptn can pull that data from that data source for the quality gate evaluation. So we kept it as open as possible.
Okay, awesome. All right, so I guess that's it. Thank you so much for joining us. I hope you enjoyed the event. Just stick around. I have a couple more questions here, but these are more from the staff. So usually Verdiarla was a face-to-face event. What do you think about this type of live events, like in this virtual pre-recorded?
I think it's challenging these days, right?
Yeah.
I think it's challenging because we have so many virtual events. I think everybody tries to figure out what's the best format. And I think everybody needs to figure out how do we not just try to force us to replicate a physical event and bring it to the virtual world, because there's certain things that's just not possible in the virtual world, but I think there's certain things possible. So I think over the last 6 months, since we've been kind of stuck at home, I've seen many different ways of doing it. There's pros and cons of the pre-recorded sessions. I really like the fact that you guys are doing at least a live Q&A like this, because otherwise everything is just recorded. So I really enjoy this. We'll see. I have to say the great thing about it is I'm in Austria right now. It's 10:30 at night. I'm enjoying my glass of wine, and I can virtually cheers, but I can virtually be with you. And otherwise, this might not be possible because I might not be able to travel to all these locations within this short amount of time. So there's always a good thing about this too.
Awesome. Are you on the event Slack org? I think that. So in case people want to learn, we always recommend to connect with others on Slack, on Discord. We have the conversation ongoing there. But on top of those topics we discuss on your talk, I think they will be able to find you online and on the GitHub repo. There's everything is pretty much in there, right?
Exactly. I think that, people can find me on Twitter. I always have the same username. It's Grabner Andy. So my last name, Grabner, and then ANDI. That's my Twitter handle. That's my, I think, LinkedIn handle.
They'll find you. Yeah, exactly. So wave to the camera. thank you so much for joining us, and hope to see you, some other time.
Gracias.
So, okay. Bien, ese fue Andreas Grabner. Ahí acabamos de terminar el Q&A con su charla, A Guide to Event-Driven SRE Inspired DevOps.